Welcome to all the students who are watching this video once again. This is grade 10 ICT tutorial, video tutorial. So far we have finished two classes, two lessons for grade 10 and we finished the fundamentals of number systems, and also we have completed basic three conversions in the last class. Conversion of a decimal number into binary, we converted a decimal into octal, and also we have done decimal to hexadecimal conversion. So hope you all took some time at home and practiced them because those three basic conversions are very important for your examinations. So as I mentioned in the last class, today we are going to take the opposite part of those three conversions. So today we will convert those three numbers, binary, octal, hexadecimal, into decimal. So without much explanation or introduction, I straight away step into the conversions. So today, remember this is the fourth conversion. So let's take the fourth one, which is binary to be converted into decimal. So let's see how a binary number to be converted into a decimal. So this is a fourth conversion. So I take a very small binary number. This is 1, 0, 1, 1. It's a binary number. So now we must find out the equivalent value of this in decimal format. So let's see how to do that. To find the decimal value, first of all you need to do one thing. Look here, look carefully. So I write it again for my convenience. 1, 0, 1, 1. So look, we have 4 digits in this number. This is a binary number which has 4 digits. 1, here 1, 0, 1. So what I'm going to do is, I'm going to write this position of these digits. So look here, I may write on the bottom part, but sometimes when you have numbers very closer, it is a little bit difficult. So I put an arrow here, and I'm going to write the position of this first digit. So it is a binary number, so it's base 2. So this first digit is in 2 to the power 0. Look carefully that this is the first digit. So always the first digit is in the 0 position. So it is 2 to the power 0 because it's a binary number. Similarly, you have to write the position of the second digit as you have written earlier. So here, this is the first 0 position, so it must be the first position. So I can write it as 2 to the power 1. Because we keep 2 here because it's a binary number. The first digit in the 0 position and the second one is in first position. So similarly, go to the third one. So now you can easily find out because you got the pattern now. So it must be 2 to the power 2 position. Finally, we have another one. So where it is, it must be in the position of 2 to the power 3. So it is important. It must be the first step in this conversion. So you have to write each and every digit as the power of 2 because it is all these digits are in different places. So we have to point out those positions. After pointing out those positions, you have to find out the value first. So look at the first position. It is 2 to the power 0. So you know, in mathematics, 0 power of any number must be 1. It may be 2 to the power 0, or it may be 10 to the power 0, it may be 16 to the power 0 or whatever. So 0 power of any number should be 1. So here 2 to the power 0, 1. And that must be multiplied with this digit, particular digit, because you mentioned 2 to the power 0 as the position of this one. So now after finding this value, you must multiply with that one. So it is 1 times 1 is 1. Apply the same method to the rest of the values. So look at the second one. Let's move to the second one. So it is 2 to the power 1. So always it's 2 into, look at the digit which belongs to this position. It's 1. So it is 2 to the power 1. So it must be 2. Go to the third digit. So it is 2 to the power 2, which is 4, into, look at the digit, it's 0. So it is 4 into 0, it's always 0. We have one more digit, that is 2 to the power 3, it's 8 into, look at the digit, it's 1. So 8 times 1, it's 8. Now we have obtained the values for each and every position. So finally, you need to add them together to get the decimal equivalent. So let's add them. It's 11. So 1011 is a binary number that is equal to 1111 base 10, which is a decimal number. So since it's a decimal number, I ignored the base. Right? So this is how a binary number is converted into decimal. I try to explain the method again. First of all, you have to write the digits, and after that you must mention the position of each digit. Since it's a binary number, it must be 2. The first digit, which is placed in the right farmost end, must be 0. Then 1, 2, 3 like that. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. After getting those values, you need to multiply the relevant by the relevant digit. Finally, add all those digits and get the sum, get the total. That must be here. According to this example, it's 11. So this is binary to decimal conversion. So let's check the other one. So hope you can understand these conversions with the help of one example. I don't want to take more than one example, because these are very simple. Even if I take another example, things are very same. So spending much time in these basic conversions are not good. So I take the number 5. This is converting an octal number into decimal. So this is octal to decimal. Converting an octal number to decimal. So again, I take an octal number. So let's take an octal number. 3, 5, base 8. Again, it's a small number. So 3, 5, base 8. Let's convert this into decimal. So even for octal to decimal, you have to use the same method as you used earlier in the binary to decimal conversion. Look at them. We have 2 digits. So I'm rewriting them. 3, 5. So first of all, we have to write the position of these 2 digits. So look at them, look at it. This 5, this digit 5 is placed or is located first. then 3. So I can write the position of this 5 as 8 to the power 0. The reason for having 8 here is it's an octal number. In the previous example, we have written that as 2 because that number was binary. That's why we have written 2 to the power 0, 2 to the power 1, 2 to the power 2. But here it's an octal number, so it must be written as 8. I put 0 because, as I mentioned earlier, the first digit which is in the right side should be 0, power. So it is 8 to the power 0. Second digit, so it must be 8 to the power 1. So since we have only 2 digits, so it is up to 8 to the power 1. There is no more digits. So what else? What's the next step? As we did earlier, you have to find out the value of this. So 8 to the power 0, this is always 1. This must be multiplied with this particular digit. So look at this. This 5 belongs to the first position. So it must be 5. It is 5. Go to the second digit. Here it is 8 to the power 1. So it's 8. Multiplication. So here we have to multiply. Look at the digit that it belongs. It is 3. So it is 3. It is 24. So now time to add them together to get the decimal value. So it is 29. So 3, 5 is an octal number that has an equal value in decimal, which is 29. So I can write it's 29. So even this example and the previous example are same. But the only difference between the previous example and this one is this. Here we mentioned as 8 to the power 0, 8 to the power 1. There we mentioned as 2 to the power 0, 2 to the power 1. The reason is very simple. It is binary. So every digit belongs to binary. It is octal. So here we have octal digits. 3, 5, they are octal digits. So that's why 8. 8. The position of those digits are same as the previous. They are 2 to the power 0. The first digit is 0. Second digit is 1. So here also see. Even the rest of the methods are similar to the previous. So here also one example is more than enough to understand the stuff. So try to practice and understand this conversion too. So straight away I will move to the third conversion, so which is converting a hexadecimal number to decimal. So let's see the method. This is number 6. Let's convert a hexadecimal number into decimal. So let's take a hexadecimal number A10 base 16. We all know that A10 is a valid number in hexadecimal because hexadecimal is a number system which has both digits as well as English letters. So here A10. Let's find out the decimal equivalent. The method to get the decimal equivalent is exactly same as the previous two methods. That's why I told you that you can remember these three conversions without any difficulties because you can find similar characteristics or similar patterns there. So what I'm going to do is I'm going to write the digits, the position of each digit first. So let's write it again, A10. So you know this is in 16 to the power 0. I put 16 because every digit is hexadecimal, so 16 is there. Since it is the first digit, I put 0. Every time when you write the first digit, it must be 0. So take the second one. It is 16, yes, but it is in the next position, so it must be 16 to the power 1. The third one, yes, it is also hexadecimal, so 16, where it is in the second position. 16 to the power 0, 16 to the power 1, and 16 to the power 2. After writing those positions, we have to find the value as we did earlier. So 16 to the power 0, it is always 1 into, look at the digit which belongs to that, it is 0. So it is 0. 1 into 0 is 0. It is 16, 1. Yes, 16 into, look at the value, it's 1. So 16 times 1 is 16. Last one, it is 16 to the power 2. It is 256 into, look here, this is slightly different because in the previous example we have only digits, those digits are on the form of numbers. But here, this is A. So according to the previous method, you have to multiply this 256 by A. But you can't multiply a number by an alphabet. But as we studied earlier, we all know that in hexadecimal, some digits are represented by alphabets, English letters. So this A represents number 10, right? So put the 10. Rather than writing a 10 here, A here, write as 10. So now 256 can be multiplied by 10. So it is 2560. Finally, add all those numbers together. So it must be 2576. So A10 is the hexadecimal number which has an equivalent in decimal, that is 2576. Right, so this is how hexadecimal is converted into decimal. So today we took 3 conversions. In all these 3 conversions, decimal number involves, right? In the first conversion, we converted a binary into decimal. In the second one, we converted an octal into decimal. Now we converted a hexadecimal into decimal. So remembering all these 3 conversions is very easy because there are characteristics, there are similar things found in all these 3 conversions. So you can find the similar characteristics remember when you are converting a number to decimal. I repeat the sentence again. When you are converting a particular number, it may be binary, it may be octal, or it may be hexadecimal. So whenever you like to convert a number to decimal, you have to write the digits in their position first. After that, find the value of those positions and multiply by the relevant digits. Finally, you have to add them together. Even in binary, you do the same thing. Octal, you will have the same idea. Even in hexadecimal, also things same. But the only difference between these 3 conversions is this one. The particular position may be different because in some cases it is binary, so you have to write 2 to the power. So in some examples they are octal, so you have to write 8 to the power. In some numbers there are hexadecimal, so you have to write 16 to the power. See, otherwise the patterns, the methods and everything is same. So as I told you earlier, this unit will be very simple if you take some time for practicing. So hope you will spend some time for managing or for practicing these questions at home. So with those practice and exercises, we will meet in the next class. So in the next class, we have to take another few conversions. Hopefully 2 or 3 conversions will be explained. Thank you for watching.